Kapag gumagawa tayo ng robot, hindi sapat na may katawan, sensors, motors, at controller lang. Kailangan din natin ng lugar kung saan natin sasabihin sa robot kung ano ang dapat niyang gawin. And that's where the Integrated Development Environment, or IDE, comes in.
Welcome to my channel, Science with a Touch of Hugot. Let's explore! Discover short stories and discover ourselves.
What is an IDE? An Integrated Development Environment, or IDE, is a software application used by programmers to write, edit, test, and upload code to a device, such as a robotics controller. Think of it as the robot programmer's workshop. Instead of using separate tools for writing code, checking errors, and sending the program to the robot, an IDE brings many of these functions together in one environment. That's why it is called integrated. The main parts of an IDE. Let's look at some common features of a robotics IDE. First is the code editor. This is where we write the instructions for our robot. For example, turn on the motor, read the sensor. If the sensor detects an obstacle, stop. These instructions are written using a programming language supported by the robotics platform. Next is the compiler or interpreter. The computer understands programming languages, but the robot's controller needs instructions in a form it can execute. The compiler helps translate our program into a form that the system can understand. Then we have error checking. An IDE can identify problems in our code, such as missing symbols, incorrect commands, or other programming errors. And finally, we have the upload or upload to board function. Once our program is ready, we can transfer it from the computer to the robot's controller. Other important IDE features. But an IDE is more than just a place to type code. For robotics, there are several other features that are especially useful. One is board and processor selection. Different robots can use different microcontrollers or development boards. The IDE needs to know which board we are programming so it can prepare the code correctly. Another is port selection. When we connect a robotics board to a computer through USB, the computer usually assigns it a communication port. We need to select the correct port so the IDE knows where to send the program. Then we have libraries. A library is a collection of pre-written code that provides functions we can use in our own program. For example, instead of writing every instruction needed to communicate with a sensor from scratch, we can use an appropriate library. This saves time and makes our programs easier to develop. Some IDEs also provide a serial monitor or similar communication tool. This allows us to see information sent by the robot while the program is running. For example, we can display the value detected by an ultrasonic sensor. Distance, 25 centimeters. If the sensor suddenly reports 0 or unexpected value, the serial monitor can help us investigate what is happening. This makes it a very useful tool for debugging. Syntax errors vs. as logic errors. When debugging a robot, it is important to understand that not all errors are the same. A syntax error happens when the code does not follow the rules of the programming language. For example, we might forget a symbol or type a command incorrectly. The IDE may detect this before the program is uploaded. But there is another kind of problem, a logic error. The program may compile successfully, but the robot does the wrong thing. For example, we may tell the robot, if the distance is less than 20 centimeters, move forward. The code may be perfectly valid, but our intended behavior was for the robot to stop. That is a logic error. And this is an important lesson in robotics. A program that compiles is not necessarily a program that works correctly, from code to robot. So what actually happens when we click upload? First, we write our source code in the IDE. The IDE checks and compiles the program. The resulting machine-readable instructions are then transferred to the robot's controller. The controller stores and executes those instructions. The robot then interacts with the physical world through its sensors and actuators. So we can think of the process as program, compile, upload, controller, sensors and actuators, robot behavior. This is the bridge between software and hardware. IDE and robotics development cycle. Robotics programming is rarely a one-click process. Instead, developers usually go through a cycle. Plan, decide what the robot should do. Code, write the instructions in the IDE. Compile, check whether the program can be built successfully. Upload, transfer the program to the controller. Test, observe the robot in the real world. Debug, find and correct problems. Then we repeat the cycle. This is why an IDE is not simply a writing tool. It becomes part of the entire robotics development process. IDE and simulation. Some robotics development environments can also work with simulation tools. A simulator allows us to test robot programs in a virtual environment before running them on physical hardware. Imagine testing a robot that is supposed to avoid obstacles. Instead of immediately risking a collision with a real robot, we can first test the behavior in simulation. This can save time, reduce hardware risks, and help us identify problems earlier. However, simulation is not always identical to reality. A real sensor may produce noisy readings. A motor may behave differently under load. Wheels may slip. So eventually, our program still needs to be tested on the actual robot. Example, Arduino IDE. One familiar example in educational robotics is the Arduino IDE. It provides a code editor where we can write our program, tools for checking and compiling the code, board and port settings, library support, and the ability to upload the program to an Arduino board. We can also use the serial monitor to observe data coming from the board. So when students use an Arduino to control LEDs, motors, or sensors, the IDE becomes the workspace where they develop the software that controls the hardware. IDE in robotics. Let's imagine that we are programming a simple robot. We want the robot to move forward. If its sensor detects an obstacle, it should stop. Our workflow might look like this. Write the code, check for errors, compile the program, upload it to the controller, then test the robot. If the robot doesn't behave as expected, we go back to the IDE, modify the code, and test again. This process is called debugging, troubleshooting robotics errors. But what happens when the robot doesn't do what we expect? This is where troubleshooting becomes important. Troubleshooting means systematically finding the cause of a problem and correcting it. Let's say we uploaded our program, but the robot isn't moving. We shouldn't immediately assume that the code is wrong. We need to check the problem step by step. First, check the code. Does the program contain syntax or compilation errors? Second, check the board and port settings. Are we programming the correct board? Is the correct communication port selected? Third, check the connection. Is the USB cable connected properly? Is the controller communicating with the computer? Fourth, check the power supply. The program may be correct, but the motors and other components still need sufficient power. Fifth, check the hardware. Are the motor wires connected? Is the sensor connected to the correct pin? Is the component itself working? And finally, check the logic of the program. Maybe the robot is moving, but in the wrong direction. Maybe the sensor is detecting an obstacle, but the robot doesn't stop. In these situations, the program may run without producing a compilation error, but the robot's behavior is still incorrect. That's why troubleshooting requires us to look at both software and hardware. Debugging with the serial monitor. One of the most useful debugging tools in many robotics IDEs is the serial monitor. Suppose our robot uses an ultrasonic sensor to measure distance. We expect the sensor to report distance 30 centimeters, but instead, we're getting 0, or a completely unexpected value. By displaying the sensor readings in the serial monitor, we can observe what the program is actually receiving. This helps us determine whether the problem is in the sensor, the wiring, the program, or the way we're processing the data. In other words, debugging gives us evidence instead of guesswork. A systematic troubleshooting process. A good robotics programmer doesn't randomly change everything when something goes wrong. Instead, troubleshoot systematically. Identify the problem. What exactly is the robot doing or not doing? Reproduce the problem. Can we make the error happen again? Check the simplest possible causes first. Look at the power, cables, ports, pins, and basic settings. Read the IDE's error messages. They often provide clues about what went wrong. Test one component at a time. For example, test the sensor separately before testing the entire robot. Make one change at a time. This helps us know which change actually solved the problem. Then test the robot again. This process is called debugging, troubleshooting, and it is a normal part of robotics development. The important lesson. Remember, an error message is not always bad news. Sometimes it is the IDE telling us exactly where to look. And when there is no error message, but the robot behaves incorrectly, that doesn't mean there is no problem. It may simply be a logic or hardware problem that requires testing and observation. So when your robot doesn't work, don't immediately say, "My program failed." Ask instead, where did the problem begin? Was it the code? The compilation? The upload? The connection? The power? The sensor? The actuator? Or the logic? That mindset is what turns a beginner into a better robotics programmer. Why is an IDE important? An IDE makes robotics programming more organized and efficient. It helps us develop programs, identify errors, and communicate our instructions to the robot controller. Without an IDE, programming a robot could involve several separate tools. With an IDE, many of those tools are integrated into one workspace. Hugot. And just like programming a robot, sometimes we also need an IDE in life, because when something goes wrong, we don't always need to start from zero. Sometimes we just need to edit the code, fix the error, and run the program again. Because a bug in the program doesn't mean the whole system is a failure, simply means there's something that needs debugging. So remember, an IDE is a software environment where we can write, edit, test, debug, and upload programs for our robot. The robot may have the hardware, but the IDE is where we develop the instructions that bring that hardware to life. I'm Ma'am Hugot, and remember, if your code doesn't work the first time, don't give up. Debug it, learn from it, and run it again.
Thank you for learning with me today. Remember, biggest classroom. Don't forget to subscribe for more lessons. Keep finding the Hugot in every day. See you in the next lesson.